All right, well, now that we're a couple of weeks into the semester here, we're actually more than halfway done. We're at the place where these assignments need to be completed correctly and nearly perfect in order for the next week to be successful. So I'm going to go ahead and step you through a very rudimentary, rough cut build of the WildWood Apartments project. And we're going to go ahead and just make sure that this is built correctly so that future assignments work properly for you. All right. So we're going to start with the sample data at our right, and we'll create a brand new model. We're going to go ahead and change the name from MyDB to, I just like to acronym it, WWA, WildWood Apartments. All right. All right. Up here at the top, we're going to go ahead and add a new diagram, a brand new fresh diagram template, and we'll just start at the top and work our way down. Complexes. So we're going to start with the complex table. Right here, add new table. Double click on it. It'll bring you up your view here at the bottom. Let's scoot that up so we can see it real clearly. We're going to call that complex. We're going to create a complex key. And looking at our information here, we actually don't see it in the complex table, but here in the apartment table, we can see the complex key is actually the 3-string variable character. And there's 3 different options, OAK, VM, and FOX. So we're going to actually change that from integer to varchar 3. That's our primary key. It's going to be not null. And we should be good to go on that. Next field. Complex name can be a varchar still. Complex phone. It's going to be a fixed length, 10 character. Complex address. We'll go ahead and leave that on varchar 45 is fine. Complex city. Complex state is a 2-letter abbreviation, so we're going to change this one to fixed character 2. And finally, our zip code. And that one's going to be a fixed character 5. All right. Again, we want to just go ahead and, for the sake of this assignment, we're going to just match our data types to what we see in front of us here. We're not going to make it any more complicated than that. Now, generally speaking, when you're doing an actual database build, you're going to want to think ahead and go, oh, okay, what are some possible outcomes of this type of build? Well, we might have those zip codes with the extension, the 4-digit extension, in which case you're going to want your zip code to be a variable character up to 10. Okay, but in this case, character 5 is just fine. Okay. Now all of these are filled in and completely present in the sample data, so we'll go ahead and make them all not null. And that says that every one of these fields must be present in the data in order for it to be entered in as a valid record. Okay, so there's our complex entity. I'm going to go ahead and create the apartment one real quick, and then I'll walk you through what I've built. All right, I've quickly built the apartment table here for you. So I went ahead and I skipped complex, and I'll tell you why in just a second, but we skipped complex. We go ahead and start with apartment key. Again, that's not present in this table, but for database optimization, we're going to want a key field for each table. So we're going to create an apartment key, and then we're going to add apartment number, number of bedrooms, number of bathrooms, and square feet. Now the apartment number, bedroom number, and square feet are all integers. However, the number of bathrooms, because we can have values of 1.5 in some records, that needs to be a decimal. Now, a common misconception is treating the comma in the inputs decimal kind of like a decimal. And so people will often put the first integer is how many numbers before the decimal, and the second integer is how many numbers after the decimal. That's not actually accurate. The first integer is the precision. It means how many significant figures are you going to allow in this number. You know, in this case, that's 2. Okay, 1 and 5, for example, over here in number of bathrooms. And then the second is the number after the decimal. So how far after the decimal are we going to allow that to go? So in this case, 2 significant figures with 1 being after the decimal point. So that's the input when you use decimal. Make sure you get those right. You want to make sure you get the length of those long enough, otherwise you'll not be able to upload your data. Okay. Again, each of these is complete and filled out, so we're going to go ahead and check not null on all of those fields. And then up here real quick in your entity design, we need to put our complex key in our apartment. Now, how would we go about doing that? We're going to create a relationship over here on the left, okay? Now, each complex can have many apartments, but each apartment will be found in only one complex. So we're going to use a many-to-one. You start with the many side first. So again, many apartments, click the apartment entity first. In each complex, click the complex once. You will get the notation with the crow's feet toward the apartment, and that will automatically grab the primary key from complex and insert it in apartment as a foreign key. Now, I don't like complex key. I think that's kind of ugly to read. I'm going to go ahead and drop out the first complex. You can rename that so that it matches, keeps it nice and tidy. It brings the data type with it. And again, it says it's not null because every apartment does need to have a complex key inserted for it. Okay? With that done, let's go ahead and start working on our tenants table. All right, so I've created my tenant table with a tenant key. Again, not present in our sample data, but we do want to have that. So we're going to give it a unique integer field as a primary key. We got our first name or given name, and we'll leave that one as a varchar 45. It's a default. Family name, same thing. Phone number, and again, we're going back to the fixed character, fixed 10-digit character. Now, why don't we use integers here? We could call that an integer. They are all numbers. We could do the same with the zip code. We could also do that as integer. The reason we don't is because the integer data type can still have arithmetic aggregation functions applied to it, sum, average, things like that, where that wouldn't really be appropriate. You wouldn't want to know the sum of phone numbers or the average of phone numbers. And so we're going to go ahead and leave that as a character type. That way nobody accidentally tries to aggregate phone numbers or zip codes. Okay? And then again, we have our tenant email. All of these are complete in the sample data, so we're going to mark them as not null. All right, let's go ahead and do the managers. Now the managers is a fun one because these are also all tenants. All right, let me get that built and then I'll walk you through it. Well, the manager table is a little bit interesting because all the managers are tenants. You can actually just add the only 2 unique pieces of information that you need to be contained solely within the manager table, and everything else will be derived from foreign keys. All right, so we've got the manager hire date and the manager monthly stipend. We don't need the manager's given name or family name because that information is already available in the tenants table, and we will reference it as the manager will pull in the tenant key as its primary key. Now you can share primary keys between tables. All right, so what we're going to do is we're going to once again create a one-to-one this time. So each manager is only one tenant record, and tenants can only be one manager record. So it's going to be actually a one-to-one relationship. We're going to again start on the manager side because this is our dependent table, and our parent table is tenant. And look what it did is automatically grabbed the tenant key and pulled it into the manager table. Now I like to put that up into primary position, so I know where my primaries are, and I'll mark that as a primary key. So now we have tenant key in the tenant table. We also have it in the manager table as a primary foreign key combo, okay? Now the only other piece of information we need is the complex information in the manager table again. Now, because we're assuming we're going to go just simple for now, because we need this to work. And I don't want to worry about being creative of what might be a problem in future hypothetical builds. We're just going to go with the sample information we have in front of us. Our relationship between manager and complex is going to stay 1-to-1 for now. We only have one manager per complex and one complex per manager. So for simplicity's sake, again, that's a 1-to-1. We're going to start on our dependent table, manager, where we want the complex ID to come into the manager table. Let's move that over a little bit, as a foreign key right there. Okay. So let's go ahead and clean up those names once again. I don't like to see the extra source table information. I don't think that's necessary. So let's clear those off. All right, now we have a cleaned up manager table. Again, I went with decimal 6-2 because we have 6 figures over here in our monthly stipend maximum with 2 after the decimal. Okay. Now let me get the lease table built out here. This is going to take me a little bit longer, and then I'll walk you through what I'm doing there. All right, I have the lease table now populated with lease key. And then looking down the data here, given name, now that's from tenant, so we're going to leave that out for now. Family name, also from tenant, we're leaving that out. Complex is from complex, we'll leave that out. And apartment number is from our apartment table. So again, none of those need to be brought in. We'll leave those all out for now. We're just going to bring in a lease key, start date, duration, deposit, and rent amount. Again, start date's a date type, duration is an integer, either 6 or 12. Deposit is 6-digit. Again, right there, 6 digits with 2 after the decimal. And the same with the rent amount. The rent amount actually could get away with 5, but I'll go ahead and for consistency's sake, make it 6. So 6 with 2 after the decimal again. Now we're going to have to go ahead and start. We're going to create some relationships. If we look through the information here real quickly, we can see that some tenants can have multiple leases, all right? And some leases can apply to multiple, some apartments can have multiple leases. I'm trying to find an example here. Well, there again, Oak 103 has 2 different leases. VM11 has 2 different leases. So again, we have 2 different leases in several of these. So these are going to be many or one-to-many relationships. So between apartment and tenant, both are going to be one-to-many lease. So again, starting here with our many-to-one, start with our dependent table, leases, and go to tenant second, and it will draw our line, pull in tenant key as a foreign key, and then we'll do that again. Click on leases first, and then apartment, and it will bring our apartment key as a foreign. Now we don't need to tie to complex. The reason for that is the complex information is already available in the apartment table. And so we can get to the apartment complex information through the apartment key. So we actually don't need that in this data set at all. Okay, if we ever need to report on things by complex, we can arrive there by going through the apartment entity and getting to complex key through there. Okay, so we can do a double table join and still arrive at that. So again, I like to tidy my stuff up here, bring up tenant key toward the top. Now, redundant information. All right. And that is our lease table. Coming down to our rent payments, I'll go ahead and build that one out and walk you through it. In our rent payment table, we have a rent payment key, again, something to give us a unique integer field to query off of and join on. We also have a date, so rent payment date, obviously a date type. Rent billed and rent paid are all both decimal. And we're going to go ahead and, once again, for consistency's sake, go with the 6, 2. Now, we do not have filled in information on every record for billed or paid. So those need to not have the not null check. Those are nullable fields, okay? We have to allow nulls in order to input these tables or these data rows. Now, why didn't we put in given name, family name, or lease start? Once again, those bits of information are found in other tables. So we need to pull in our lease information. Now, if we pull in lease, we will be able to get to tenant because tenant is a key in lease. And so we'll be able to get to tenant name. We'll be able to get to lease start date. So that all that information is accessible through the lease entity as we go into rent payment. So let's go ahead and once again, each lease is going to pay rent multiple times, right? We've got Mark Patterson here paying rent or billing and paying rent. So we got multiple things. So once again, you click your one-to-many, select your dependent table, in this case, the rent payment, then select your primary table, and we'll have our crow's-foot notation with toward the rent payment table, and it will insert the lease key as a foreign key in there. Once again, like to move that up to about where it fits in the data block. And then let's get rid of that table information right there. Again, lease key does need to be not null. We definitely want that information present here. Now let's get our last couple tables built. Let's do maintenance requests, and I'll go ahead and do both of these real quick. Maintenance requests and expenses, and we'll get them joined in. All right, got these two tables built up now. We're going to go ahead and join them into everything else. So starting with maintenance requests, get the request ID, date entered. We skipped the tenant name, complex, and apartment information. We're going to join those in just a second. We do need to have the date entered. That's unique information from this data table. The problem and the date closed and the resolution. Now, you'll notice the date closed isn't always populated. In this case, we have a field right here that's not resolved yet. So we need to leave the request date closed and the resolution both need to be unchecked. So they need to allow nulls. Now, once you've got those all done and in there, we need to go ahead and pull in tenant. And we're going to assume that any given tenant, like Robert Woodward here, can submit more than one maintenance request. So we're going to say maintenance request is going to be on the many side of a many to one. Each maintenance request is only going to have one customer or one tenant, excuse me. So we're looking over there for our tenant table. Let's grab maintenance and bring it a little closer over here. Sorry, I'm trying to work with half a screen. Many to one, start on your dependent table, maintenance request, then select your parent table tenant, and it will bring in your tenant key information right here. All right, now we also need, because we don't really know what lease any of these maintenance requests belong to, we could probably figure it out based on the date it was entered, but that's probably a little bit more complicated than it needs to be, and the maintenance request is not necessarily a function of the lease. So we don't necessarily want those linked. But we do know that we have a tenant making the request, and it applies to an apartment number. Now, again, that apartment will be in a given complex, so we don't need to bring in complex information because we can already arrive at complex by way of the apartment. So all we need to do is bring in the apartment now. So again, the same apartment can have multiple requests, as we have again here with Richard Woodward in apartment 12. So we're going to go with our one-to-many, select our dependent table maintenance requests first. Come on up here to your apartment table second, and it will bring in your apartment key as a foreign key in maintenance request. Okay, so once again, we're going to clean up our names. And reposition these just because I like to keep them a little bit more tidy. You'll also see why this is useful when we go to enter the data. All right, so there's our maintenance request. Let's go ahead and scoot that down and put it up here between. Let's tidy this up a smidge. There we go. There we go. Trying to keep this thing readable. There we go. And now let's tie in our expenses. We have expense key, date paid, category, payee, description, and expense amount. There again, I've expanded the description to varchar 200 just because I don't want to run out of information. People could get really lengthy as to why they request or need to pay an expense. And our amounts can be a 6,2 decimal. We need to bring in complex and request key. So let's go ahead and set that guy over here between complex and maintenance requests so they don't cross my lines all up. Again, just trying to keep things tidy. So each complex, once again, can have many expenses. So we're going to grab our many to 1, click on expense, then complex, so bring in our complex key right there. Clean that up. All right, and also, as you look at our sample data, complex key is sometimes null. So we're going to go ahead and deselect not null on complex key, allowing nulls there. And our last join now is going to be from expense to maintenance request. Let's go back and double check our data, make sure that we do. See, maintenance request number 5. We can have multiple expenses to one maintenance request. So again, one to many, starting with expense. Parent is maintenance request. Let's try that again. Expense, then maintenance, so that our crow's feet are on expense, and it draws in the maintenance request ID as a foreign key. Once again, let's clean that up. And reposition it. Also, as we review our sample data, our risk request keys sometimes are blank. So we need to deselect not null and allow nulls for request key. All right, now that covers all of the information in the sample data. All of the tables are linked. Each has at least one join. Foreign keys are present and accounted for. And that will get you a functional database. Okay, we need to all get on the same page so that you guys can continue to finish out the semester with working data models. All right, so please, if you have not built it to a functional point, please follow these instructions and reconstruct your data model, and then we'll export that out to the database. All right. If you run into any problems or difficulties or questions as you go through this, write them down, screen capture, or if you can, and post to the discussion board so that we can talk about it and help you solve it. But again, by the end of this week, we all need to be on the same page so that you can continue to finish out the semester without trying to backtrack and rebuild, okay? So again, database, forward engineer. We're gonna drop objects before create and generate drop schema. All right, next. Now I would execute this on mine. Actually, I think, yeah, I can't. For some reason, this is a particular trick to mine. I have a versioning problem between my workbench and my SQL Server backend, and it doesn't like this keyword visible. So I can't actually export it like this. I'll show you. I will copy this to clipboard real fast. And next, then it says, oh, it doesn't like it. So there's a problem with what you wrote here. So something's wrong with the syntax near the use of the word visible. So I don't know quite how to fix that. I've worked on it a couple times, but in the sake of time, I haven't completely solved it. Either way, I've got the data, the script now. I can go back here, open up a local instance, paste that script, and then all I just have to do is do a quick find and replace. I'm going to find visible, and I'm going to replace it with nothing, and that clears all those out. Execute the script, and it built my table. So over here on the left and refresh all, and there's my WildWood apartments tables: apartment complex, expense, lease, maintenance request, manager, rent payment, and tenant. All of those are ready for data input. And I'll start another video to walk you through some data input tricks and making sure we get all of the correct data input into these tables.